Okay, hey students, so this group we're going to be going over three problems on conic sections. So let's go ahead and take a look at question number one. So on question one, we have to find the equation of the graph. Okay, so this is a copy of the graph here. So we can clearly see that this is a hyperbola. So the question is, which of these equations match this graph? Okay, so first thing we're going to do, let us take a look at how many units we're going in all directions. Um, well, how about we graph the center first? Let's graph the center. So this right here are the coordinates of the center. So the center is basically 3 units to the left, 1, 2, 3, -3, and then we go up uh, 1, 2, 3, 4. So -3, comma 4. So in the equation, we're going to have the opposite of these. So we can have, now since the orientation of our parabola is hyperbola is side to side, that means that x is going to be positive and y will be negative. Okay, so we're going to have x, and then the opposite of that, plus 3, quantity square, minus, and then for the y, we're going to have y, the opposite of plus 4 is minus 4, quantity square. Okay? All right, so just by graphing that, we can clearly see that the answer is going to be option letter A. Just to make sure, for the denominators, basically, we're going side to side 3 units. So since we're going side to side 3, under the x, we're going to have 3 square. All right? And then since we're going up and down 2 units, under the y, we're going to have 2 square, and that equals 1. And if we simplify it, we're going to have x plus 3 quantity square over 9 minus y minus 4 square over 4 equals 1. And our final answer is going to be option letter A. Okay? So that's that. All right, let's take a look at question number 2. It says graph 4x squared plus y squared equals 36. Okay, so let's go ahead and do that. So for number 2, we have 4x squared plus y squared equals 36. Now to put it in a standard form, we cannot have any coefficients in front of the x squared or the y squared. So in order to, and then we also have to have this set equal to 1, all right? Remember the standard form for the equation of an ellipse is basically x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? So we have two goals in mind. First of all, we want to get rid of this coefficient of the x squared, and we also want to make this a 1. Okay? So in order to accomplish that, if we divide both sides by 36, that will be sufficient. So let's go ahead and do that. We're going to divide every single term by 36. Okay? So we'll divide this term by 36, divide this by 36, and divide that by 36. All right? All right, so 4 goes into 36 9 times, so we have x squared over 9 plus y squared over 36 equals 1. Okay? Now, since there's no number next to the x, we can write this as x minus 0 squared over 9 plus y minus 0 squared over 36 equals 1. All right, so what does this information tell us about the ellipse? Well, it tells us that the center is 0, comma 0, and then the direction of uh, direction of axis, square root of 9 equals 3, and that's going to be side to side because it's under the x-axis. And then the square root of 36 is 6 up and down because that's under the y. Okay, so which graph has a center around 0, 0? Let's take a look at our options right here. Now we can clearly see that options C and D are not the answers because these are hyperbolas. This is a parabola because you have two squares, different denominators, and a plus. Okay, so that automatically qualifies this as an ellipse. So C and D are eliminated. We're looking at option A or B. If you notice, these two options have the centers and the origin. But let's look at the direction of the axis. Okay, so we're supposed to go side to side 3 units. That is option B. And then up and down 1, 2, 3, 4, 5, 6. So we can clearly see that the correct answer is option B because it matches the direction of our axis that we determined by taking the square root of the numbers under each variable square. Okay? All right. Now let's take a look at question number 3. All right, so question 3, it says find the center and radius of that conic right there. So let's go ahead and write it down for number 3. We have x squared plus y squared plus 2xy, and plus 2x minus 10y plus 10 equals 0. All right, now this is clearly a circle because you have two squares of plus and the coefficients are both identical for the square, so this is going to be a circle. All right, in order to find the center and the radius, we have to write this in standard form. This is the general form of the equation of a circle. So to do that, we're going to place the x's next to each other. So this x and this x, we have x squared plus 2x. And then the y's next to each other, y squared and 10y. So we have plus y squared minus 10y. This constant needs to be shifted to the right. It's neither x nor y, so subtract 10 from both sides. So we have this whole expression equals negative 10. Negative 10. All right, so what we're going to do now is partition the variables down the center into the x and y worlds. And then we're going to complete the square in their respective world, okay? So there goes your partition. Now to complete the square in the x world, we need to do b over 2 square in the x world and also in the y world. So b in the x world is 2, okay? So in order to complete the square, we need to divide this by 2, which is equal to 1, and then square it, and then get 1. So that completes the square in the x world, okay? And then in the y world, we're going to go b of y is negative 10. Divide that by 2, we get negative 5. And when we square that, we get 25. All right, so that completes the square in the y world. All right, so let's go ahead and insert those values. So we're going to have x squared plus 2x plus 1, and then plus y squared minus 10y plus 25 equals, now we're going to negative 10, we're going to add these two numbers that we added on here to the right side. So we're going to have plus 1 plus 25. Okay? All right, let's go ahead and factor these. Now to factor these, all you do is you're going to, for the x world, you square the first and the last, and then bring down the middle sign. And then the same procedure in the x world too. But let's do the x in the y world too. Let's do the x world first. So if you square root x squared, you have x plus the square root of 1 is 1 square. Okay, plus. Now do the same thing in the y world. You square root the y squared and the 25. So you're going to have quantity y. Bring down the middle sign. Y minus 5 quantity squared. And then 10 minus, negative 10 plus 26 is simply 16. Okay? All right, now this is the equation of a circle in standard form. Now the center, remember we have to take the opposite of the numbers next to each variable. It's going to be negative 1 for the x coordinate, and then positive 5 for the y coordinate. All right? And then for the radius, you take the square root of the last number. You don't just take the last number the way it is. You have to take the square root. Square root of 16 equals 4. So your final answer is going to be option letter D. All right? Good day, students. In this clip, we're going to be going over sequences and series in this review part. So let's take a look at question number 4. It says the number of lilies a large nursery can sell each day after April 1st is modeled by a sequence whose general term is a sub n equals 1700 minus 75n, where n is the number of days after April 1st. Find the number of lilies that can be sold on April 6th, 7th, and 8th. Okay, so you have to remember, note that we're looking for the days after April 1st, okay? So On April 2nd, for April 2nd, we're going to have n equals 1 for April 2nd. And then for April 3rd, we're going to have n equals 2. So basically, we just subtract 1 from the date, okay? All right, so now what we're going to do is look at the pattern, and we notice that it's basically 1 less, okay? So we're going all the way to April 6th. So if n equals 1 for a second, then we know that for the fourth day is going to be n equals 3. For the fifth day, n is going to be equal to 4. And then for the sixth day, n is equal to 5. So we're basically using n equals 5 to find out, to plug into this formula. Okay, so the explicit formula, an is equal to 1700 minus 75n. So this is a explicit formula for an arithmetic series because the n is not exponentiated, okay? So for the sixth day, for April 6th, we're going to have April 6th, we're going to have n equals 5, okay, because we started from April 2nd to count, so we kind of like behind by 1. All right, so we're going to plug that there. So a sub 5 is going to be 1700 minus 75 times 5, okay? And then for April 7th, what do you think we're going to have? N equals 6, right? So n equals 6, then that will be a sub 6 equals 1700 minus 75 times 6. And then for April 7th, for April 8th is going to be 75 times 7. Okay, so if we work out 2, that should be sufficient for us to determine what the answer is. All right, so let's bring out our calculators and try this out. So we're going to compute what these expressions equal. So we're going to have, for the 6th day, April 6th, 1700 minus 75 times 5. And the answer is 1325. So it looks like option A is the answer there, option A. Let's do this April 7th just to make sure. So 1700 minus 75 times 6. And we have 1200 and 1250. Okay, so 1325 and 1250, let's write that down. 1325 and 1250, we can clearly see that option A is our answer, okay, because that's the one that matches. All right, so we have to be really careful. We got to start counting from April 2nd because this formula works for days after April 1st. All right. Okay, now let's move on to question number 5. It says, find the sum of the infinite series. So it's an infinite series. The question is it geometric or arithmetic? We can only find the sum of infinite geometric series. Okay, so when talking about infinite series, there's only geometric series that has convergence. All right, so this is an infinite geometric series, and the formula for the infinite geometric series, S of infinity, is equal to a1 over 1 minus r. Okay, a1 is the first term, which is 20, and r is what you get when you divide the second term by the first term, or term divided by a term before it. Okay, so a2 is negative 15, and a1 is 20. Okay, if you divide this out, divide top and bottom by 5, you have negative 3 over 4. You notice that this common ratio is between 1 and negative 1. That is why we can actually compute the infinite sum. All right, because of the convergent series. So S of infinity is going to be 20 over 1 minus negative 3 over 4. Okay, so it's going to become 20 over 1 plus 3 over 4, because minus times minus is a plus. Express this as a fraction, multiply by 4 top and bottom. Multiply by 4, multiply by 4. And then you're going to have 20 divided by 4 over 4 plus 3 over 4. So we have 20 divided by 7 over 4. Now multiply the numerator by the reciprocal of the denominator times 4 over 7. Multiplying across, your final answer will be 80 over 7. So the answer is option letter C for number 5. All right, let's take a look at question number 6. We're asked to find the sum of this series right here. Now let's take a look at it. For number 6, this series is expressed in sigma notation. So we're going from n equals 5 to 20 of 6n plus 23. Now, this series is an arithmetic series because the variable is not exponentiated. Okay, this variable or power, then it will be a geometric series. Okay, so since it's an arithmetic series, we have to use the appropriate formula for the sum of n terms of an arithmetic series. S of n is equal to n over 2 times a1 plus an. Okay, all right, so in this case, let's find n first. N is simply the last term minus the first term plus 1. Okay, so basically how many numbers are there from 5 to 20? Okay, so it's going to be 15 plus 1, which is 16. All right, so n is 16. Now, the first term a1 is what you get when you plug in the lower bound into the variable. Okay, like that. So you're going to have a1 is going to be 6 times 5 plus 23. So it's basically 30 plus 23, which equals 53. Okay? And then a sub n is what you get when you plug the upper bound into the variable, plug in 20 into n. So you have 6 times 20 plus 23. So 6 times 20 is 120 plus 23, which equals 143. Okay? All right, so what we're going to do is put all these together into the formula. So we're going to have S of n is going to be n over 2, 16 over 2, times a1, 53, plus an, 143. Okay? It's basically going to be 8 times 196. Okay? All right, let's compute that with our calculators. So let's do this. 8 times 196. So our answer is 1,568. So Sn is 1,568. And we can clearly see that our answer is option letter A. Okay? All right, let's take a look at question number 7. Now I'm going to shift gears and work on infinite limits for a second. So we have to find the limit as x goes to infinity of negative x to the 4th minus 8x to the 3rd plus 4x squared minus 15x plus 22. And then that divided by 5x to the 4th plus x to the 3rd plus x squared minus 5x minus 8. Now if you look at since this is a limit involving infinity, we can observe the weights, okay? So if you notice that in this case, we have equal weights because the degree of the numerator is 4 and the degree of the denominator is 4 also, okay? So since they have equal degrees, all we're just going to do is extract those two and just divide them, and then that will tell us what the limit is, okay? So we're going to take the limit as x approaches infinity of negative x to the 4th over 5x to the 4th, okay? So the x to the 4 goes here once, x to the 4 goes there once, and then you're going to have the limit as x approaches infinity of -1 over 5. Okay? Since this limit, since there's no more variable here, this limit, this value is independent of where x goes, so your final answer is simply going to be -1 over 5. So we can clearly see that our answer is option letter A. All right, let's move on to question 8. It's a finite limit. So we are to find, for number 8, the limit as x approaches 7 of x squared minus 49 over x minus 7. Okay? We can clearly see that if we just substitute 7 directly into the variables, plug in 7 here and plug in 7 there, we're going to run into some complications because we have 7 squared minus 49 over 7 minus 7. And then we have 49 minus 49 over 0. Okay, when you have a 0 on the bottom, is undefined. You can't find out what the limit is. So since we have that issue, that means we need to go back here and simplify first, okay? So we have the limit as x approaches 7. Now we can factor the numerator. Since it's a difference of squares, we just take the square root of the first and the last and write the sum and the difference of the square roots. That over x minus 7. Okay? And then now let's see what happens. We can divide it. X minus 7 goes here 1. X minus 7 goes here 1. So we're going to have the limit as x approaches 7 of x plus 7. Okay? And now what we're going to do is we can just plug in 7 into the this expression without any issues here because the discontinuity was a removable discontinuity. Okay? So plug it in. So we have 7 plus 7, which equals 14. So that's the limit of this expression as x approaches 7. So we can clearly see that our answer is option letter C. Okay? There you have it. Okay, let's move on to question number 9. Question 9. It's another limit problem. So we have to find question 9. Find the limit as h approaches 0 of 7 plus h. I'm sorry, f of 7 plus h minus f of 7 over h if f of x equals x squared plus 5x. Okay? All right, so we're going to break this down. We can't plug in 0 exactly into this because we have some problems in the denominator. Let's find out what each of these functions are, and then we're going to plug it in, okay? So f of 7 plus h is a composite function. So what does that mean? It means that we're going to be substituting this expression into the x's in this function, okay? So we know f of x is x squared plus 5x. So anywhere we have the x's, we replace with 7 plus h. Okay, so instead of x squared, we're going to have 7 plus h, quantity squared, plus 5 times, and instead of x again, we're going to replace it with 7 plus h. All right, and then now let's simplify this. We're going to have 7 plus h times 7 plus h because of the square. And then distribute this 5 to both terms in the parentheses, plus 35 plus 5h. Okay, and now let's follow this out. First outer inner last. First is 49. Outer is 7h, inner is 7h. Last is h squared plus 35 plus 5h. All right, let's combine like terms here. We have h squared, and then we have 7h, 7h, 5h. 14 plus 5 is 19, plus 19h. And then 49 plus 35, 4 carry 1 is 84. Okay? All right. Now, let's look for f of 7. F of 7, this basically means that wherever we have x, we will plug in 7 into the original function. Okay, so instead of x squared plus 7, x squared plus 5x, we're going to have 7 squared plus 5 times 7. Okay? Alright, so there you have it. Okay, so if we work this out, we're going to have 7 squared is 49 plus 35. 49 plus 35 is 84. Okay? Alright, so we're gonna put everything together into this limit and then evaluate what the limit is, okay? So it's now gonna become the limit as h approaches 0 of h squared plus 19h plus 84 minus 84. This whole expression is f of 7 plus h, and this is f of 7. This whole story divided by h. Divide this by h. All right, so we can plug in 0 here also because we still have h in the bottom, and that's a problem. So let's simplify it as much as we can first, okay? So 84 minus 84 is 0. And then we have the limit as h approaches 0 of h squared plus 19h over h. Now we can factor out the h from the numerator, so we have the limit as h approaches 0 of h times h plus 19 over h. Okay, I can divide these two h's, and then you're going to have the limits as h approaches 0 of h plus 19. Okay, so we're going to plug in 0 into this expression. We have 0 plus 19, and our final answer is 19, and that's option letter A. Okay, so there you have it. All right, in this part, we're going to be going over polar and rectangular coordinates and equations, how to graph and convert from one form to the other. Okay, so let's go ahead and start out by taking a look at question number 10. It says, which of the following is not a representation of the point P? All right, so let's grab this image real quick. All right, so let's label the relevant angles. We notice we have pi negative 11 pi over 6, pi over 6, 7 pi over 6. So if you refer to your unit circle, you know that this angular measure right here is pi over 6, or it's 30 degrees. This is pi over 6. This right here is 11 pi over 6. Uh, and then since this is pi, if this is pi, then this has to be 7 pi over 6 because you're adding pi to pi over 6. Okay? All right, so which of these do not match with that? We have 4 and negative 11 pi over 6. So let's look for, I want to look for 4 and pi over 6 first. Where is 4 comma pi over 11 pi over 6? So 4 and 11 pi over 6 is going to be, this is 4 units. 11 pi over 6 is going to be right here. Now, since the angle is negative, since we're going to 4 and negative 11 pi over 6, since the angle is negative, what kind of reflection is that? Well, that simply means we're going to reflect up and down. Anytime the angle is negative, it's an up or down reflection. Since we're downstairs, we're going to reflect straight up. So do we end up at P? Absolutely. So that means that this answer A, option A, is good. So this is a good answer actually. Okay. All right. Now let's see if the next point ends up at P. The next option is 4 and pi over 6. 4 and pi over 6. 1, 2, 3, 4. Pi over 6. Perfect. It matches. So option B is also good because it takes us right to the point we want. 4 and pi over 6 is also good. All right. Let's take a look at option C. Negative 4 and 7 pi over 6. Okay, so first of all, let's graph where is 4 and let's graph 4 and 7 pi over 6 first. And then we're going to do our appropriate reflection to see where it takes us. All right, so 4 and 7 pi over 6, we can clearly see that 7 power 6 is right here, so 4, this is 4, and if you go around to 7 power 6, it's going to take you right here. Now, since you have a negative radial measure, since r is negative, what does that mean? If r is negative, that means you reflect along the radius, okay? You reflect along the radius, a radial reflection. So since 4 is negative, we're going to reflect along this line, and guess what? It takes us right to P. So what does that mean? That means that negative 4 and 7 pi over 6 is also good. Okay? All right, let's take a look at the last one, which should be the answer. How about negative 4 and 11 pi over 6? Okay? So to do that, let's first of all graph the positive angle, 4 and 11 pi over 6, and see where the reflection takes us. Okay? So 4 and 11 pi over 6. 4 and 11 pi over 6 is right here. So when you negate if you negate the radius, what does that mean? If you have a negative r, it's a radial reflection like we just talked about. You reflect around the radius. Okay? So if we wanted to graph negative 4 and 11 pi over 6, we have to reflect along this line, and it takes us right there. So this point is negative 4 and 11 pi over 6. And what does that tell us? It's not a match. It does not fall on P because when reflected, it ends up right there. Okay? So option D is wrong. So answer to number 10 is D. Okay? All right. Now let's move on to question number 11. All right. 11, it says, what are the rectangular coordinates of the point with polar coordinates 8 and pi over 6? So with this one, we're just going to make use of the conversion formulas. Number 11, we have a polar 8 pi over 6, and then we are asked to change it to rectangular. Okay, so we're going from polar to rectangular, and we know that rectangular is x comma y. This is rectangular, and this is polar. Okay, polar is r theta, rectangular is xy. Okay, so to find x, we're going to use a formula. If you refer to your formula sheet, r cosine theta is how you find the x coordinate, r cosine theta. Okay, and then we know that r is 8 and theta is pi over 6, so we're going to have 8 cosine pi over 6. Okay, cosine pi over 6, if you refer to your chart, is root 3 over 2, so we're going to have 8 times root 3 over 2. If you multiply it across, you have 8 root 3 over 2. Okay, so you notice that we can divide by 2 top and bottom. 2 goes here 1, 2 goes here 4. So this is going to be equal to 4 root 3 for x. How do you find y? Y is r sine theta. Okay, using the formula on your formula sheet, so we have 8 sine pi over 6. So sine pi over 6 is 1/2. So 1/2 of 8 is simply 4. Okay, so that's y. So our conversion to rectangular form, so 8 pi over 6 in polar, if you convert it to rectangular, is going to be 4 root 3, comma 4 in rectangular form. Okay, so that clearly tells us that our answer is option C. All right, let's move on to question number 12. It says, which of the following polar coordinates describe that point given there? So we're going to be converting from rectangular to polar in this situation. Okay, so for question 12, we have 7 root 3 comma 7. This is rectangular, okay, because we're asked to convert to polar and there isn't any angular measure in the y coordinate. So this is rectangular, so that means this is x and y. We are going to change this into polar form, okay? And what is polar? Polar coordinates are given by r and theta, okay? All right, so to find r, if you refer to your formula sheet, r is the square root of x squared plus y squared, okay? So that's going to be the square root of 7 root 3 square plus 7 square. All right, 7 root 3 square, you're going to square 7 and root 3. So 7 squared is 49, and root 3 squared is 3. 7 squared is 49. Okay? All right, so when we combine these two, 49 times 3 is 196. 196 plus 49. 196 plus 49. I'm sorry, it's not 196, it's 147. So, yeah, 49 times 3 is 147. And 147 plus 49 is 196. And the square root of 196 is 14. Okay? Alright, to find theta, we're going to use the formula sheet again. Look for the inverse tan of y over x. Okay? Alright, so that's going to be the inverse tan of 7 over 7 root 3. Okay? So we can divide by 7, top and bottom. That gives us the inverse tan of 1 over root 3. Since we cannot have a square root in the denominator, we can rationalize the denominator root 3, and we'll multiply across. It's going to become the inverse tan of root 3 over 3. Okay? And if you refer to your table of concentric angles, you can clearly see that the inverse tan of root 3 over 3 is 30 degrees or pi over 6. Okay? Well, we're working with degree measure here, so we're going to use 30 degrees. All right? So the rectangular coordinate 7 root 3, when changed into polar, is going to be r14 and theta of 30 degrees. This is the polar representation. Okay? It's r theta. So our answer is going to be option A. Okay? All right. Now let's move on to question 13. It says, what are the polar coordinates of the points with the given rectangular coordinates? So in this case, we're going from polar to rectangular again. So, all right, so for 13, uh, we have -5, -4. This is rectangular. So this is going to be xy, and we're going to convert it into polar, right? Polar is r comma theta. All right, so let's start off by looking for r. So if you look at your formula sheet like we did before, r is the square root of x squared plus y squared. So it's going to be the square root of -5 squared plus -4 squared. Okay? Alright, now we'll work that out. We're going to have the square root of -5 squared is 25 plus 4 squared is 16, which equals the square root of 41. Okay? So that's r. Okay, now we need to find theta. To find theta, we're going to compute the inverse tan of y over x. Okay? So we're going to have the inverse tan of y is -4 over x -5. Minus over minus is plus, right? So this is simply going to be the inverse tan of 4 over 5. Okay, so the rectangular coordinate -5 comma -4. is the same thing as the polar coordinate root 41, comma, the inverse tan of 4 over 5. Okay, so there goes your answer. So you can see the answer is option letter A, or 13. All right, let's move along to question number 14. We're dealing with equations now. So here we're asked to convert x squared plus y squared equals 81 into uh, polar equation. Remember, rectangle has xy polars r and theta. So in this equation, x squared plus y squared, we can only, if when converted to polar form, we can only have r and theta. Okay, so we're going to be making use of the formulas we already knew before. R is equal to the square root of x squared plus y squared. Okay, and we also know that uh, theta is equal to the inverse tan of y over x. All right, so there you have it. Okay, so in order for us to make a substitution here, you know that r is the square root of x squared plus y squared. I have x squared plus y squared here, so in order to make it in a form consistent with what r is, what I'm going to do is take the square root of both sides, so I can have a reason to substitute for r. Okay, so this is square root of x squared plus y squared, so we know that this whole expression is going to reduce to r, and then the square root of 81 is 9. Okay, so r equals 9 is your answer. So the answer to options to number 14 is letter C. All right, let's move on to 15. It says, what is the polar form of the equation 5x plus 3y equals 5? 5x plus 3y equals 5. All right, so for this one, we're changing this to polar also. So we know that x, let's write that in red. We know that x is equal to r cosine theta, and y is equal to r sine theta. Okay, so we're gonna go ahead and make that substitution here with the x and the y's. So um, 5 instead of x is going to be r cosine theta, plus 3 for the y is going to be r sine theta. Okay, equals 5. Remember, when you're converting from rectangular to polar, all the x and y's have to be substituted with something else. Okay, they have to be gone. You can only have r and theta in an equation that is in polar form. Okay, all right, so we have this expression, so we're gonna simplify it a little bit more. So we have 5r cosine theta plus 3r sine theta equals 5. You notice that r is common on both sides of this equation, so we can factor that out. R times 5 cosine theta plus 3 sine theta equals 5. Okay? Alright, and then to finish this off, we just basically divide both sides by 5 cosine theta and 3 sine theta. So we have, divide this by 5 cosine theta plus 3 sine theta. We just want to get r isolated. That's why we're doing this division. Okay? 5 cosine theta plus 3 sine theta on both sides. This divides out. So we're going to have r equals 5 over 5 cosine theta plus 3 sine theta. Okay? So we can clearly see that our answer is option letter C. So that's our answer for number 15. All right, let's move along to question 16. So question 16, we're asked to express x plus 4 square plus y squared equals 16 in polar equation form. This is what is the polar equation of for the circle with the equation with this equation. So let's go ahead and write this down for question 16. We have x plus 4 square plus y square equals 16. Okay, so we just need to remember that um, r equals the square root of x squared plus y squared. Okay, and then also that x is equal to r cosine theta. So that's another point to keep in mind, and y is equal to r sine theta. Alright, so let's go ahead and expand this first and see what we have. So x plus 4 squared is x plus 4 times x plus 4 plus y squared equals 16. So we'll follow this out. We're going to have x squared plus 4x plus 4x plus 16 plus y squared equals 16. And then we can see this x squared and the y squared. We can combine them together. Put these next to each other. We have x squared plus y squared. And then 4 plus 4 is 8x plus 8x plus 16 equals 16. Okay? Alright, so another point to note also is that since r is the square root of x squared plus y squared, by extension, if I square both sides, r squared is equal to x squared plus y squared. So anytime you have x squared plus y squared, you can replace it with r squared, since r is the square root of x squared plus y squared, okay? So since you have x squared plus y squared here, without a square root, that means that r is simply being squared to get rid of the square root. So we're going to make a substitution here, x squared plus y squared with r squared plus 8. Now what is x? X is r cosine theta, right? So I'm going to make another substitution here. Instead of x, I'm going to replace it with r cosine theta plus 16 is equal to 16. All right. Okay, next step, we're going to subtract 16 from both sides. And then we can even subtract 8r cosine theta in order to get r isolated. But let's subtract 16 first. So we're going to have r squared plus 8r cosine theta equals 0. So now let's subtract 8r cosine theta from both sides. 8r cosine theta and 8r cosine theta. So we're going to have r squared equals negative 8r cosine theta. And since r is common on both sides, we can actually divide both sides by r. So divide this by r and divide that by r. So you're going to have r equals negative 8 cosine theta. Okay, so this is your polar coordinate form for your result. So the answer is going to be option letter B. Alright, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this presentation. I appreciate it. More clips can be found on mathgoodserve.com. Thanks again, and have a wonderful day.